So in the last video, we figured out that we had this airplane. It was flying on a compass heading 170 degrees at 460 miles per hour. So we found that that was this vector right here. Then the wind was blowing at a bearing of 200 degrees at 80 miles per hour. Okay, so basically what happened was we figured out like what is the vector that goes between these two. And we found that it was 52.517 and then negative 528.187. So basically what's happening, see this purple vector? That's the plane. Then we've got the wind going this way. Now technically what's actually happening is the wind is over here and it's like blowing on the plane, right? Well, what we know is that we can add those two together like this, and given they're not to scale at all. But when I put those two together, then I get this third line. Let's see if I can find kind of a bright. This third, like the resulting vector is this. And so I find that it's actually going this way. So let's grab those things and put them in with the next, let's put them in with the next slide, which asks the next question. And the next question is, all right, so we've got this plane going. So what's the ground speed and what's the direction of the plane? So we know that the plane was headed this way, but the wind was headed that way. Again, this is not, like it's not to scale. But this right here, we know this one, the resulting vector, that ended up being, that ended up being 52.517 and then negative 528.817 or 187. All right, so that really means it's going, so 52. So actually 52 is actually this way and then way the heck down. So how did that happen? Well, this vector right here, I just kind of drew them. This one's probably, this green one probably should have been a lot shorter. And, but do you get the basics? So the plane's going this way and then the wind is blowing against it. So not drawn to scale, but you get the gist of what's happening, and then I put this together. And this blue line actually comes out to be over here. So actually should be over here. Again, fine. Now, how do I find the ground speed? Well, the ground speed is going to be the magnitude of this. Do you remember how to do the magnitude? It's a squared plus b squared equals c squared. So I'm just going to take 52.517 squared plus, in parentheses, negative 528.187 all squared. That's going to give me the magnitude, but then that equals c squared, don't forget. So originally we said distance formula, but distance formula is a squared plus b squared equals c squared. So I'm going to pull up my handy dandy little calculator. I'm going to shrink it down because it doesn't need to be that big. And so we've got what? 52.517 all squared plus, I'm just going to type in 528.187 all squared because it's negative times a negative ends up being the same thing. Okay, enter. Okay, then I second square root, second answer. So what is the resultant? I think, do you see what I did? I missed something. Okay, so 52.517 all squared plus 528.187 all squared. Enter. Second square, second answer. Okay, so about 527. Is that what you got? I see, I mistyped something again. Oh my gosh. 52.517. 52.517 all squared plus 528.187 squared second square root second answer. Okay, now am I right? Yes. Finally got what my answer key says. So 530.775. 530. So 530, like about 531-ish miles per hour. Okay, that's going pretty darn fast. Now, what can I do to find, like, what is my angle on that? Well, this angle, again, was not drawn exactly, but the way I find it is I just go, I know that the tangent of theta equals rise over run, y over x. Okay, well, negative 528.187 divided by 52.517. Okay, so I tan inverse that. So second tangent negative 528.187 divided by 52.517, close my parentheses. So negative 84.332 degrees. Okay, so what does that mean? That means right here, can we undo that? Okay, so what should have happened was this little one should have been a ton smaller, and this one maybe a bit bigger. So this one kind of should have been like, this one would have been little, and then the blue one would come over to here, so it's at about 84-ish degrees. Is that about 84 degrees now? Yeah, negative 84 right there. Okay, so there you go. It's okay to have negative. That could also be called, if I went the other way, that would be 275.678 degrees. So that is, like, that's how the programs that the air traffic controllers are using, they take into account how fast and what trajectory the plane is going, and then the wind, and that helps them get to the right place, and they just do all the calculations from there. Super cool.